Hi, this is AI Wisdom that gives you the AI wisdom. In this video, I'll be going to cover the top-down algorithm for the longest common subsequence problem. This is a more intuitive algorithm for you to understand, therefore I start with it first. Now let's consider the algorithm, which is putting here. Now the LCS I and j, what is I and j? I and j is the index of the two strings we want to compare. So let's assume the first string is ABCD and the second string is AC. Now we'll be starting at position 0. I is the position of S1, j is the position of S2. Now position 0 we have A and A, so those are equal. And for the equal case, we'll be using a 1 plus 1 because they are equal, so at least we have a length of 1. And we'll be comparing the remaining BCD for the I plus 1 and C for the J plus 1. And for this, we'll be getting the result. Let's say if consider the case where the S2, we have different character at the position 0. So we'll be going to the max branch. And for the max branch, what it does is that since we are different for the beginning, so what I will do is that I will try to compare S1 with the one character omitted and consider the D. Or we will be considering the ABCD with the A omitted and considering the BD branch. So this is the second case and this is the first case. So by doing these two comparison and we take the max, we'll be able to get the LCS of the cases starting from 0. Now let me depict this using the example here. So for the example here, we have S1, the string we want to compare ABCD and S2 with BD, and we have the index for the string putting here for your reference. Now we're starting at the case of 0, 0, and for 0, 0 we will be comparing A and B, which is different, so we'll be going to the max branch. And for the max branch, there are two cases, 1, 0 and 0, 1, as I mentioned to you. So we'll be doing the left branch first because we are doing a recursion. So for the left branch, we'll be continue here for the 1 plus branch because we are the same for the 1 and 0. And for the 1 plus branch, we have this 2, 1, so we'll be comparing C and D. And since they are different, we are going to the max branch again for 3, 1 and 2, 2. For 2, 2, the second 2 is out of the bound here. There is no 2 here, so we don't consider this. And for 3, 1, since we are the same for the last character, then we'll be returning a 1 here. And since this is the maximum of 1 and nothing, we'll be getting a 1 here. Since this is a 1 plus 1 and this will be a 2 here, so we'll be returning a 2 to the root node. Remember that we are exploring this just now, but we haven't gone through that yet because we'll be exploring the left branch first. Now since we are going to the right branch, we'll be continue to this, and to this. And for this, we observe that it is exactly the same as this one. So rather than going forward to do the same stuff again, we can record the things to make it more efficient. Now this is the key here. So the record of the things, we call it a memorization. If you record the things, your space and time, your space will be not so good because you spend extra memory to record the things, but your time will be reducing from exponential to a polynomial. If you don't record the things, you'll be doing things again and again, so ultimately you'll be getting a 2 to the power of m plus n. N is the length of S1 and S2 respectively. Now for the space wise, we have a maximum of m and n, because you can see the tree. We explore one branch at one time, and the longest branch we can explore is the maximum of the length of S1 or S2. Therefore, we have this. And for the time wise, because repeated explorer, so we have a 2 to the power of m plus n, which is very bad. So we need some memorization, use some space to make the time better. So I'll be talking about how to record this later. So let's continue with the explanation just now. So with this 2, 1, since the answer is 1 here, and we are recording it, we detect that this is a non-zero in the memorization table. So we'll be return a 1, and to this, since this is a 1, 2, which is out of the scope of the S2, so we'll be disregard that, and then we will return a 1 here. And for this one, since this is a max branch, we'll be returning a 1 here, and taking the max of 2 and 1, we'll be getting a 2. Now the ultimate LCS is a 2 here. Now, how to introduce a memorization here? Very simple. We just record the answer in a table. So for the IJ, the answer, the result is this one and this one. So we record it to a table, and whenever we detect that, since the table is initialized with 0, if we detect that the value is larger than 0, we will be using this value, and this is the memorization. So with the memorization table, for the cases of A, B, C, D, and BD is like this. So we will be extending one more column and one more row here. For the purpose will be introduced later. Now let's say if we explore to this branch 1, so we record the value here. So the orange here meaning that we'll be starting from this cell. Now 2, 1 will be record the value here. So I'll be circle whenever there is a record, and I'll be circle according to the sequence that is recorded. Now for the 1, 0, you'll be this one, and then you'll be coming down here 2, 1. So the same thing, since we are getting the value from here 1, we don't record it again, and we're getting a value for 1, 1, and we have a 0, 1, and finally we get a value of 2. Now using this table, we are able to get back the result of the longest common subsequent string, which is BD. Now how do we get it? We are starting from the ultimate outcome. So this is the position we'll be starting. Now looking at these two, we compare it to the bottom and to the right. Is there anything that is equal to 2? Yes. If yes, then we move down. This is a 2. Now we compare to the bottom and the right. Is there anything equal? No. Then the value must be coming from diagonally. So we draw an arrow here. So this is a 1. And since 1 is increased to 2, then B must be the character that contribute to the longest common subsequence in this case. Now since we are at the 1 here, we'll be comparing the right and the bottom. Is there anything equal? Yes. We move down here. And since we have a 0 here as well, and since this is increased from 0 to 1, and we draw an arrow here, then D must be the character that contribute to the length of the longest common subsequence. So now I explain why we need a 0 here. This is for the purpose of easy programming, where you can easily observe that there is a jump from 0 to 1 without the need for you to do some extra checking. And for there are some cells we didn't populate any value, so they will be remaining 0 as well. So you can see that for the top-down method, we didn't really go through all the possible cases. We only go through certain cases and memorize the value down, and some cases they will be remaining at their initial value. So this is about the top-down method of the LCS. Please like the video if you feel that it helps you, and please subscribe to the channel if you want to find out more materials useful for your AI wisdom. I will be continuously updating materials that are related to AI, such as machine learning, data science, and algorithm in this channel. See you then!